let's talk about logarithms. Here, lesson 87, we're evaluating them. Just a reminder, whenever you have two factors and they're multiplying, log base b of mn is multiplying, that means you separate the two by addition, meaning log base b of m plus log base b of n. So they're separated and they have their equal logs and the same base. Whenever you have an exponent, so log base b of m to the n power, the exponent now becomes a number in front. It's multiplying into the whole thing. You have to expand it your own by yourself. So here, n times log base b of m. Here we're going to have different ways we're going to be solving for the logarithms. And here, again, you can't just use your calculator log because the log button in your calculator is log base 10. That's the common log. And later on we'll show you how to change the bases there. So now we have log base 4 of 16x cubed. First thing you do, so remember there was three of them. The first one was a multiplication one, that means you add. The second one was division, I don't have up there, but if it's a divided by b, that means it's log base b of a minus log base b of b. So therefore, here this is, you see an exponent, you always work your way down. You always make sure, are there any exponents? Okay, no. If there's any, are there any things you can divide? Okay, no. Are there anything you can multiply? So therefore you always work backwards. In this case, there's an exponent. We want to move the exponent up front. So now we have 3, I'm going to put parentheses, log base 4 of 16x. So I'm going to go parentheses there. And then I move on. Is there anything else I can use? So I've used my exponent one. Is there anything multiplying? So therefore I can expand it. In this case, yes, there is something I can multiply. So the 3 I'm going to leave out, so I'm leaving it on the side. Now I'm going to go ahead and expand it. Log base 4 of 16 plus log base 4 of x. Now I solve for each one separately. So if I look at this one, I'm just going to take just this one out. Log base 4 of 16. So log base 4 of 16. If I set it equal to y, I can solve for it. Let's put up here. So the log base a of x is y. Whenever you're changing from logarithm to exponential form, it's your base, which is a, to your solution, so to the y power, is equal to x. So it's your base to the y power is equal to x. So here, if I'm trying to solve for log base 4 of 16, I can put in exponential form. To put in exponential form, it's going to be 4 to the y power is equal to 16. And then 4 to what power gives you 16? 2. So that logarithm can be solved. So I'm going to put it over here. Now it's going to put it over here. So now I have 3 times, now my log base 4 of 16 turns into 2. Plus the log of 4 to the x power. Now let's go ahead and put what x is. According to this, x is 256. So now I have 3 times 2 plus log base 4 of 256. Again, same thing. I take the log base 4 of 256. I put it in exponential form. Log base 4 of 256 equals, I'm going to put y. I don't want to put x because we have something else for x. So now, again, this would be 4 to the y power gives you 256. And if you just do 4 squared, 4 cubed, 4 to the 4th power, you end up with y being equal to 4. So that means to simplify this, I'm going to go ahead and erase this. I have now 3 times 2 plus 4. So my log base 4 of 16 turned into 2 because of the work here. My log base 4 of 256 turned into 4. And now I go ahead and add and simplify. So simplify, 2 plus 4 is 6. 3 times 6 is 18. And therefore you get your answer. I'm just seeing if I got the work right here. And I did. Okay. So then your answer would be 18 from this point. Let's do another one, B. Now we're dealing with natural log. So natural log of 7e squared. So first thing, you work backwards. So look up here. Always make sure, are there any exponents? Yes, there is. Let's go ahead and move it. Now we have 2 natural log of 7e. Now, let's go back over here. Let's go ahead and see if there's anything multiplying. In this case, yes, there is. The 7 and e are multiplying. Let's go ahead and expand it. So the 2 I'm leaving on the outside. I have the natural log of 7 plus the natural log of e. If you remember, the natural log of e always turns into 1. So I'm going to put that up here. Natural log of e equals 1 because they cancel out. Now I have 2 times the natural log of 7 plus 1. And natural logs you could do in your calculator. So if I put natural log of 7 in my calculator, I get 1.95 plus 1, which is 2.95 times 2. And the answer for all of this here would be about 5.9. So natural logs, typically you'll solve them out with your calculator. So you're expanding it, always make sure you're working backwards from this to this. You're always using this method here from going from exponential to logarithm to exponential form. That's why I gave you that worksheet a month ago, about changing them back and forth because we'll be using it for this lesson. Now to change base, whenever you're changing base, it's always log base a of xy. Our calculators don't do regular logs. They only do the common log, which is log base 10. So if you see log of x, that means log base 10 of x. Here, we can change it. So to change it, we have log base a of xy. To change it, all you do is do the log of your x function. Your x is that number right here. So log of whatever's on that number, your factor there, log of x, y, divided by your base. So the log of whatever your base is. So let's go ahead and do example 2. Here it says log base 100 of 10x squared when x is equal to 100. So we're going to go ahead and just apply the methods. Here we have a 2. We can go ahead and move it up here. So 2 times the log of 100, 10x. And now if you notice here, we have the log of 100. Let's go ahead and change the base to that. According to the work here, when you're changing the base, it's your number of here, you're doing your log of 10x divided by your base. Your base is 100. So now I change the base, so it's the 10 divided by log of 100. Again, these are now considered common log. We can go ahead and simplify this even more because 10x means that they're multiplying. Meaning we go to that step up here, we go ahead and expand it. So we have 2 times log of 10 plus log of x over log of 100. Log 10, log of x over log of 100. Let's go ahead and put our x equals 1,000. So we have 2 times the log of 10 plus the log of x, which is now 1,000, divided by your log of 100. If you remember about log of 10, log of 100, you can do that in your calculator and that will give you a whole number. What I do, a little trick for it, when you're doing this type of problems, whenever you're doing the log of 10, 100, 1,000, you always count the number of zeros. The log of 10 is 1. Log of 1,000 is 3. You can double check in your calculator. If you put log of 1,000, you'll end up with 3. So for me, I just count by the zeros. Log of 100, 2. Now we can simplify this even more. 1 plus 3 is 4 divided by 2. 2 times 2, my answer is 4. So that's how you would simplify. You expand it, see if there's any properties here, and then try to apply the change base law as much as you can. And now let's go ahead and do B. When you're changing your base to a log, you can do the same exact way by doing natural log. So here it says they want you to change it to the base E, which is a natural log. E and natural log ln, they go hand in hand when x is equal to 6. So over here, just like example 2a, we're going to go ahead and move the 3 in front. So 3 times the log of 4. We don't focus on the 3 or the exponent until the very, very end. So 3 log 4 of 2x. Let's go ahead and change the base here. So to change the base, just like I put the log of my main factor over the log of my base, instead of using log, we're doing the same exact way, but we're just using natural log, so ln. So now, it's the natural log of your base, or your main number here, which is 2x, over your natural log of 4. Now looking at this, I can simplify because natural log of 2x, going back to the rule here, they're multiplying. When you have two factors multiplying, you expand them by adding. So natural log of 2 plus the natural log of x over natural log of 4. This could be simplified again. Now I said x is equal to 6. That means, move over here, we have 3 times your natural log of 2 plus your natural log of, put in parentheses here, 6 over natural log of 4. When you have natural logs, use your calculator. So for me, I simplified all of it, and I got, so the natural log of 2 in my calculator, I got 0.69. My natural log of 6, I got 1.79. Again, it's just using your calculator and entering them in. I just rounded to the hundredths. You may be off by a couple decimals, but if you're off by a couple, I don't count that wrong. If you're off by a couple like whole numbers, then that's different. Now, this is simplified to this is simplified to this. Natural log of 4 is equal to 1.39. So now I added, I divided, and I multiplied by 3. So you add it, then you divide it, multiply by 3, and I get about 5.53. That's just to save time there. So you're working step by step, changing the bases if needed, and you go ahead and solve right here. Example 3, we want to solve for x. So in this case, you actually see this a lot, especially for next year, you'll see this a lot. You have 1,000 to the 9x power is equal to 100. We're going to go ahead and change it and put it into logarithm form. So now instead of putting exponential form, we're going to do log form. That means your 1,000 was considered your base. So log of 1,000. And then remember your exponent was your solution on the outside, which is 9x. And then your solution here was considered your x value, which is 100. And this goes back to, let's put it up here, log, I'm just going to do backwards. So a to the y power equals x. To put in logarithm form, it's a log base a of x is equal to y. Don't remember, just go back to your book and they have it working backwards. So here, I went from exponential to logarithm form. I have this over here. Now the next step, I go ahead and simplify even more. I use a change base. So here I have log base of 1,000. So to change the base, change base, I'm going to do log of my main factor, 100, over my log of my base, which is 1,000. This is going to equal 9x. Remember, with 100, 1,000, 1 million, anything with 1 and then as much zeros, all you do is just add the number of zeros. So log of 100 is 2, log of 1,000 is 3, is equal to 9x. That means to get the 9 by itself, you divide both sides by 9, or divide both sides by 9, or in this case, I'm going to multiply by the reciprocal because I have a fraction. So when I multiply by the reciprocal, I get 2 over 27, and that's considered your answer. Example 4, the very last one, is you're using a little bit of chemistry, whatever, this is physical science. But here in the book, it has a word problem. We have Newton's law of cooling. Here we have the rate with the object cools. Here we have the formula. It can be used to determine the desired temperature of the object. So T is considered desired temperature. Lowercase t is number of minutes. R is the environment temperature. K, lowercase k is the number that they gave us, kind of like a constant. And your C is 4.007. C means something, but they don't have it here. So here it says solve the formula and determine the amount of time needed to cool a cup of water from 80 degrees to 55 degrees in room temperature. Here's the desired temperature. We didn't want 80 degrees. We started with 80, but we want it to be 55 degrees. Here it says from 80 degrees to 55 in the room temperature of 25 degrees. So here's the environment temperature. According to the room temperature was 25 degrees. So that's considered our environment temperature. So that means that 80 degrees has nothing to do with this problem. Here they want to know the time after, how long it will take to cool down from 55 or 80 to 55. So what we do, we have the equation up here. And here, I'm going to put it in terms of just T. So then all I have to do is just plug it in from here. So I'm going to go ahead and find T at this moment here. It looks like for here, I can go ahead and subtract R. I just want the R out of the way. So we have that equal sign. Go ahead and separate it. So T minus R is equal to E, K, T plus C. Right there. If you notice, there's no logarithm. There's no natural log here. So I'm going to add it. So to add it, I'm going to multiply both sides. If you see the E here, I'm going to multiply both sides by the natural log. So when I multiply both sides by the natural log, I have the natural log of t minus r. It's combined, so I can't do anything there. Is equal to the natural log of e to the kt plus c power. If you remember one of the rules, I think it was inverse. Whenever you have the natural log of e, this cancels out. And you end up with just the exponent. So kt plus c is equal to the natural log of t minus r. We're trying to get the t by itself, right? I'm going to go ahead and subtract c into both sides. So then I have the inverse of t minus r minus c is equal to k times t. I want the t by itself, divided by k. So then my t is equal to this equation right here. But now, I have to go ahead and plug everything in that I know. So according to this, I'm going to put t in this, I know. T is equal to the natural log of capital T minus r minus c over k. I have everything I need. Natural log, so to fill it in. Natural log of t is considered the desired temperature, that is considered 55 degrees. Minus r is the room temperature, the environment temperature, which is 25 degrees. Minus c, your c here, they gave it to us, they didn't tell us what it was. It's 4.0073, they gave us a number. So all of this minus c divided by k. K is considered negative 0.2000064. And then you work step by step to solve for each one of these. So the natural log, I simplified all this, so I did 55 minus 25, and I found the natural log of that. And then you subtract it by negative 4.0073. I ended up with about negative 0.6061 over this whole denominator here. So again, I'm not going to show you all the work, it's going to take forever. But then you go ahead and simplify. So I divide those two, negative, negative, I get a positive. I get about 3.03. And T, they put it in terms of minutes. So to cool from 80 degrees to 55 degrees and room temperature of 25 degrees, it will take about 3 minutes for it to cool. So you're going to use those equations. I think that's in your homework too. Just make sure you go step by step, solve for the variable, and then just plug in everything in that you need to know. So if you need any help, my email's on there. Have a good day.